Let's now look at what happens when the values that the agents have for items are not necessarily private and independent. And to start the discussion, let's think about an intuitive scenario. You're in an auction and there are 100 people there beside you bidding, and you bid $1,000 and you won. This painting that you've always wanted is now yours for $1,000. And now you found out what everybody else bid, and you find out that the second highest bidder was 200. Nobody bid other than you above 200. You probably feel a little strange now. And what that really means is that the value you attached to the painting was probably too high, because not everybody else is stupid. And that may mean that your value for the painting was not just a function of your type, your private information, but also the types of the other agents. And so in general, we distinguish between, as we've seen so far, private values where agents know their own payoffs, and their only uncertainty that arises is from not knowing that of the payoffs to other agents, and therefore the strategic behavior of the other agents. So we call this pure strategic uncertainty. Contrast this with our painting example, where you have also, call it payoff uncertainty. You really don't know for sure what this painting is worth. This complicates the picture. Let's look at the special case of common values, where there's not merely correlation between the values that agents have to an item, but in fact the value is identical, and the only difference is in the assessment of that value by the different parties. And a good example are drilling rights to an oil field. After all, there'll be some amount of oil there. It'll be more or less difficult to extract that oil. Oil prices on the global market will be what they are, and all of those factors are the same for all the bidders. The only difference is the different parties may assess those quantities differently. So imagine the following very simple scenario. There is this oil field, and it can have one of three values of oil. Think of it, the combination of the quantity of the oil and the difficulty of extracting it, the prices, what have you. It can have a value of 10, a value of 20, and a value of 30. These two companies are bidding and doing their own research and reaching their own independent conclusions. What do they know when they're about to bid? Well, the results of their research will yield the following. If the value is 10, then they will get a signal that it's low. If the value is 30, they will get the signal high, and this is true for both of them. It's only in the intermediate case where there's the value of 20, then one of them will get the signal low and the other will get the signal high. And there's an equal chance that the one or the other will get the low and high signal. This is the information present. These are the types, and you see that these types are identical here. So what we have here? We have here the bids that can be made are any number between 0 and 30. It's common knowledge that it's, of course, at least 0 and no more than 30. The types are the signals they get, either low or high. And the utility is 0 if they, so it's a function of the bids made and the types of the agents. So if the agent loses, obviously the payoff is 0. If the types are high, then if both types are high, then by definition the value is 30, and therefore the winner's payoff is 30 minus their bid. Similarly, if both types are low, the payoff is 10 minus the bid. And in the final case, in which the two types are different, namely one is high and one is low, then by definition the value is 20 and the payoff is 20 minus the bid. And again, I just want to emphasize that this is true for both agents, and so it's really a common values case. They have the same value as function of their two types. So let's think about this auction, and let's assume that this is a second price auction. They will both bid, the highest will win, and they will pay the price of the lowest of the other guy, the second highest bidder. And let's try what was the equilibrium, in fact the dominant strategy equilibrium in the independent private value case, and let everybody bid their expected value as a function of their type. So if you see low, what should you bid? Well, there are two possibilities. You would see low in one of two cases. Either the oil was worth 10 or it was worth 20, because if it was worth 30 then you would get the signal high. And what's the probability that you'd get each of these things would occur? Well, if it's worth 10, that's we assume that that's a probability a quarter, and if it's worth 20, then there's that's probability 1/2, and there's an equal chance that you get a low and a high in that situation. So again, there's a quarter chance that you will get a signal low in the case of 20. So when you get low, there's an equal chance of the oil being worth 10 and 20. And so in expectation, when you get the signal low, the value of the oil field will be 15. So you would bid 15. You could do the same sort of calculation in the case of the signal high, and you would get that in expectation it would be the average of 10 and 30, namely 25. And so you end up with this following strategy. If you see low, bid 15. If you see high, bid 25. And the question is this an equilibrium? Well, let's see. So let's say that you got the signal low, and then, as the strategy prescribed, you bid 15. Well, if you got the signal low, then there are two possibilities. The other guy got low or got high. If the other guy got low, which is this case right here, then by definition that would only happen when the field was worth 10. You really don't want to win right now, because if you're bidding 15, the other guy is also bidding 15 as the strategy prescribed, then the winner will be paying the second highest, which is 15, and will be losing on the deal because it's only worth 10. So your expected loss here is not 5, because there'll be this tie between you and the other bidder will be broken randomly, and so rather than in expectation losing 5 in this case, you would be losing half of that, namely 2.5. If the other guy sees high, then they'll be bidding 25, and so you'll be losing the auction in any case. So overall, what is your expected payoff when you see the signal low, when your type is low? It's half of minus 2.5 and half of 0, namely minus 1 1/4. So you're better off not bidding rather than bidding this supposed equilibrium strategy. So obviously something has gone wrong here, and we cannot naively apply the analysis of the independent price of value, which is very simple in the case of second price auction. to the common value case. And what happens here is that in common value, and more generally when the values are correlated, if you're the highest bidder, that means that you're the most optimistic of all the bidders, by definition. Now, if you bid naively, then it means almost by definition that you're overly optimistic. Think again about that painting, the worth that where you bid $1,000 and everybody else bid less than 200. Probably you were overly optimistic about the value of this painting. And this is called the winner's curse. That sometimes people say that in such settings, when you find out that you're the winner, you feel sick to your stomach. You need to do something a little more sophisticated in these settings to avoid the winner's curse. So what might you do? Let's hypothesize the following equilibrium. So when you see low, rather than naively bid 15, bid 10. And when you see high, rather than bid 25, bid 30. And the claim is that this is an equilibrium. As a side note, equilibrium analysis is a funny sort of business. It's often very difficult to compute the equilibrium, but very easy to verify it once you found it. And so we're just positing this as an equilibrium. Let's see if indeed it is one. First of all, what happens if we see low? Then the strategy says bid 10. Let's again look at the two cases. If the other guy saw low, then it's worth 10, and you're both bidding and paying 10. You would not benefit by deviating in either direction. So that's, we're okay there. What about if the other guy sees high? Well, if the other guy sees high, and then by definition it's worth 20, and the other guy is bidding 30. So in order to win, you'd have to bid at least 30 and pay 30, and you're not going to gain anything from it. And so no sense in deviating. So it means that so long as you see low, bidding 10, in fact, would be the right thing to do in equilibrium. How about if you see high? Then the strategy says in that case bid 30. Again, two possibilities. If the other guy sees low, then by definition it's worth 20. Now in equilibrium, the other guy would be bidding 10. And so you'll be paying 10, and that's great. You'll win, and no deviation would let you win and pay any less. So we're fine there. And finally, if the other guy is bidding, has the signal high, then again in equilibrium they'd be bidding 30. You'd be bidding 30. You have an equal chance of winning it and breaking even. And if you didn't bid, you would not win it and break even, so no need to deviate there either. And so that shows you that in all situations there's no need to deviate, and therefore this hypothesized equilibrium in fact is an equilibrium.